All right. Well, good afternoon, everybody. Good morning to those in the Mountain and West Coast time zones. Welcome to the StorTrends Virtual Lunch and Learn. My name is Tyler Newberry. I'll be your host and moderator for today's Lunch and Learn. With me today is our Director of StorTrends Solutions, Justin Bagby. He'll be joining us in just a moment, but wanted to let everyone know a few quick things before we got started. Number one, if you are in a pizza delivery zone and requested a pizza during your registration, that pizza should be arriving within the next few minutes if it hasn't already. Sometimes the delivery person runs a few minutes behind. If they are running late, we just ask that you please be patient and be sure to let me know, though, if your pizza has not arrived by 1:10 or 1:15 Eastern Time or so. Email is the quickest way to let me know if your pizza has not arrived on time, and my email is tylerin@ami.com, and that's listed up on your chat screen as well. And also another reminder that if you are on the West Coast, your pizza will be arriving at 11 a.m. Pacific time, as this is the earliest that restaurants on the West Coast can deliver. Number two, please ask us questions. We want to provide as much of an interactive experience for all of you as we can. So feel free to shoot your questions over on the Q&A communicator located at the bottom right-hand corner of your screen. And we will either answer your question live on air or we will send you a message back on Q&A communicator. And finally, we do experience technical difficulties from time to time, such as losing audio or the screen may become grainy from time to time. This is pretty rare, but as you all know, technical glitches can happen, at a moment's notice. So just please be patient there while we kind of get things straightened out on our end. But like I said, very rare. But other than that, that's all I got. I'd like to go ahead and get started with the presentation. So I'm going to go ahead and turn it over to our Solutions Director, Justin Bagby. Justin, they're all yours.
All right. Thanks, Tyler. Good morning, everyone. Good afternoon to those of you on the West Coast. We appreciate you joining us today. It looks like we've got a full house here on Event Center from WebEx. So packed house, good thing. Lots of people interested in all-flash, hybrid, and spinning disk, kind of where the market's going, and maybe you're here to determine what's right for you as a next step from a product perspective to fill the need for your SAN or NAS that's currently in your infrastructure. My name is Justin Bagby. I'm the Director of Solutions and Solutions Engineering within the StorTrends division at American Megatrends Incorporated. This is my 17th year with American Megatrends, so I've been here a long time. Started off in the RAID group, and we'll refresh your memory on some of those products that AMI has brought to market and kind of give you some overview on that as we get started here in the presentation. Just going to quickly show you the agenda that we're going to follow today. We're going to go through this PowerPoint here. It's going to take us about 35 or 40 minutes to go through the PowerPoint, and then we're going to wrap up with about a 10 to 15-minute demo, and then we're going to get to some of the questions that you guys and gals have sent in to us during your registration. We do have a lot of questions. We've got looks like over 60 questions already that came in during registration, and we've got others that are coming through Q&A and chat right now. So if you do have questions, keep those coming. We've got a couple gentlemen here in the room that are going to try to answer those questions on chat and Q&A, and I'll get to as many of those that came in during the registration as we can at the end of the presentation, the end of the demo. All right, so just really quickly, we're going to go through an introduction to AMI. We're going to tell you a little bit about American Megatrends Incorporated, jog your memory so that you know who we are and where we came from and what we're doing today. Talk a little bit about StorTrends, give you a glimpse into the product lineup there. We'll talk about the storage landscape and how things are changing in the storage industry. Then we're going to move into an all-flash SAN versus a hybrid versus a spinning disk comparison. We'll talk about the different features. We're going to talk about price points. We're going to talk about the pricing of where each of those come in today from a market perspective. Then we're going to move into a technology introduction. We'll close that out with a storage support summary, and then we'll jump into a StorTrends all-flash demo. And again, at the very end, we're going to come back to the to the summary and the Q&A session. Okay, so American Megatrends Incorporated, better known as AMI. We were founded in 1985 in Atlanta, Georgia, where our corporate headquarters is located. We have a worldwide presence with 11 offices. We have a little over 1,400 employees. About 80% of our employees operate in an engineering capacity. We're not a huge marketing machine. We're not a huge sales machine. We create products that work for you and your infrastructure. AMI products are shipped in more than half of the computers in the world today. Because of that, we have over billions of products sold. From an innovative perspective, we have 375-plus company patents. We have 128 granted patents solely in storage alone. So on the StorTrends product line that we're going to talk about today, it's heavily patented technology. It's written from the ground up by American Megatrends Incorporated solely for the use as a storage array or a storage appliance. We're ISO 9001 certified 2008, and our mission statement is providing our customers the highest quality products the first time, every time. All right, so do you know AMI? When we ask that question, most people tell us, yeah, you're the BIOS guys, and that is correct. We started in 1985. We actually didn't start as a BIOS manufacturer. We started as a motherboard manufacturer. The first product that we designed in 1985 was a motherboard for Michael Dell. It was known as PC Limited at that time. He didn't have Dell Inc. at that point in time. So we designed a 386 cache-based motherboard for him. We needed a system BIOS on that board, and IBM was the only game in town. That's where you had to go and license your system BIOS from. They were charging an arm and a leg for the BIOS, so our CEO and some of our founders decided it would be in our best interest to create a BIOS for our motherboards. Little did we know that that would be a product in itself to carry the company forward for many, many years. We're still the #1 BIOS manufacturer in the world today. It's called Aptio. There's about a 65% chance if you reboot the computer that you're watching this presentation on today, you'll see the American Megatrends logo and all of our copyright information and the BIOS date and the BIOS version number on the reboot screen. So the AMI BIOS is shipped on millions of PCs every year, from servers, storage arrays, desktops, embedded systems, thin clients, notebooks, and laptops. They all use a system BIOS, and there's about a 65% chance that it's an AMI BIOS on that platform. The next product that you might not know us from is called a backplane controller. We're the #1 OEM sourced backplane controller in the world. We developed the MG backplane controller line in 2009. What the backplanes are used for is they go on the system backplanes inside of your servers and your workstations and your storage arrays, and they're providing the LED and sensor control for those SAS, SATA, and NVMe drives on the front end. So when you walk into your data center and you see all the beautiful lights and the different blinking patterns, that's what's being driven by this backplane controller. It's driving those different blinking patterns in the LEDs. Another product that you use probably daily, and again, you just don't know that it's American Megatrends under the hood, is your remote KVM, remote IPMI, and virtual USB redirection. So if you use any type of a card from Dell, like a Dell DRAC or an HP ILO or a IBM RSA, Supermicro SuperDoctor, the list kind of goes on. You pick your flavor of your server or your storage array, and the management that they use for that IPMI, KVM, and USB, it's MegaRack technology. So we created this in 1997. We called it the MegaRack G card. It was a PCI-based card that sat in the PCI slot of your server. In 1998, it was adopted by Dell. It was called the DRAC card. So again, if you've used this IPMI, KVM, and USB to remotely manage your servers and your storage arrays from home or from your office or wherever in the world, that's the MegaRack technology that's being deployed in those servers and storage arrays to do that management. The next product we're just going to quickly touch on here, and this is where we really got our start in the storage industry. A lot of people say, well, I didn't know you were in storage. Well, we've been in storage since 1994. We created a RAID card called MegaRAID. This became the #1 RAID controller in the world just in one short year in 1995. So Gartner recognized AMI and MegaRAID as the #1 RAID vendor in their Magic Quadrant for 6 straight years. We sold this off to the LSI Logic division in 2001, which is now Avago, which is now Broadcom. And so the reason we sold this division off, we were making PCI-based cards, as you see here on the screen. All of the server manufacturers wanted the technology to become an ASIC. They didn't want to put a card in anymore. They wanted to solder an actual ASIC down on the server boards. We're not an ASIC company. We didn't have a foundry. So it was in our best interest to find a suitor that could do that, and LSI Logic was a perfect match. LSI still ships this card today. It's still the #1 RAID card in the world, even after all of this time. So it's been almost 20 years since we developed this card, and that's just a testament to how strong our technology is that we design and we build, that we put out into the market. So there's a very good chance that in your Dell servers, your HP servers, your Supermicro servers, whomever server you're using today, there's a MegaRAID card or a MegaRAID controller in that device. That's your system RAID. All right, so the data storage evolution. Let's just take a second here and just talk a little about how we've evolved as a storage. And if you look at EMC's roadmap, NetApp's roadmap, you kind of pick your storage vendor, it's going to look very similar to this. We were all shipping spinning disk back 2007 and previous. And most of those boxes were dual controller boxes at the time. They had anywhere from 16 to 24 HDDs in the box. Most vendors could mix NL SAS drives, which are your 7,200 RPM drives, with SAS drives, which were either 10K or 15K RPM drives. And they could scale anywhere from 1 to 256 terabytes. Some boxes went up to petabytes. But each of those devices could pump out a max of about 4,800 ops. That's if you had all SAS 15K drives in the array. But that's kind of where we were limited. So everybody used spinning disk. Everybody had a number of ops. If you needed more ops, more performance, you had to stack more boxes. So you would have a data center that would have possibly a full rack of storage, maybe racks of storage in your specific data center to fit your performance requirement and your capacity requirement. Then a few years later, in 2012, you started seeing hybrid arrays pop up. These arrays would come with either 4 or 6 SSDs in the front end, and they would have 10 to 12 HDDs in the back end. The SSDs would give you the performance spike that you needed to reduce the latency and improve the op count, and the HDDs would give you the storage capacity that you needed to really have a lot of the capacity space to store the colder data that's sitting in that array or sitting in that storage pool. And again, they could scale anywhere from 1 terabyte up to 256 terabytes. There was 1 or 2 vendors that could go beyond that, but it really started off a lot lower. But your ops, you can see what the ops jumped to. The ops went to 200,000 ops with a hybrid array. So we went from a 4,800 op 3U system to a 200,000 op 3U system. So SSDs really changed the landscape of the storage industry quickly in 2010, 11, and 12 when these products were being released. Then fast forward to 2015, and you started seeing a lot of all-flash arrays. All-flash arrays, there were a lot of talk about all-flash arrays in 2013, 2014, but they were really expensive. Most people couldn't obtain them. They were very, 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 very highly priced. And then vendors started being able to put in deduplication, compression. They started the ability to use drives that were less enterprise. You started seeing people move away from SLC drives down into MLC drives and whatnot. And it really brought the price point down. Then we were very fortunate to where we had 6 or 7 different SSD vendors competing with each other for the small market that was there. So the SSD vendors got very aggressive, and when that happened, the price point really started to fall. So in 2015 was really the first year that all-flash arrays started getting into the SME and SMB price point realm, and that's when we started shipping them into those customer bases. The 3610 came out with 16 SSDs. It was a 3U 16-bay box. We have what we call a write-intensive or a hot tier and a read-intensive or a cold tier inside of the box, up to 256 terabytes, and it could do 200,000 ops as well. Again, the biggest difference between the hybrid and the all-flash, the hybrid didn't support dedupe and compression, the all-flash did. And now we're in 2016, and we've got the StorTrends 2610. This is the smaller brother to the 3610. I call it smaller because it's a 2U. The 3610 is a 3U, hence the 3 and the 2 in the product models. The 2610 comes with 24 SSDs. It's a 2U 24-bay box. Again, it has the write-intensive, the read-intensive SSDs inside of the array. Supports up to 256 terabytes, and we can go up to 250,000 ops in the box. So let's take just a couple minutes here and talk a little bit about our customers, who we sell to, kind of where our systems are deployed. So we have thousands and thousands of systems deployed worldwide, StorTrends appliances, and they're in all types of verticals. We're asked all the time by analysts and marketing people, who's your niche market? Who do you really sell to? It's really anybody that needs data storage. That's the beauty of this product. It's not limited to a certain niche or anything of that nature. Educational, advanced research, finance, healthcare. We come across specific items that we have to support. For example, in the healthcare industry, we're in 4 of the top 10 radiology companies in the world, and those radiology companies use a product called Imagine. It's a database that does their scanning, it does their system-level scheduling for their radiologists. So you have to support certain things of that nature for that product, but it's something that becomes in our abstract layer of our product. It's something we can easily add into our product. So we're not forced into a specific niche. We can support anybody and everybody with all of your requirements that are out there. So speaking of that, who do we sell to? Let's take a look at some of the StorTrends customer examples that we've got on the screen. This is just kind of a marketing collage that shows you some of those different aspects that we touch. You're going to see education in here. You're going to see UT Dallas. You're going to see University of Maryland, University of Georgia. You're going to see law firms in here. You're going to see Bender & Bender. You're going to see retail stores. We're in Walgreens stores. You're going to see all different types of niches and customers and market segments that are sitting here. So again, where our sweet spots at that we sell to and where these boxes really excel is anybody looking from just a handful of terabytes up to about 250 terabytes. That's where we play. We're an iSCSI only vendor, so we do not go beyond the SME market. We do have enterprise installs, but we're usually the secondary or the tertiary storage in their infrastructure. We're not their primary because we do not have a fiber channel interface. So if you have a fiber channel interface today and you're on this call, how do I use this product? We're iSCSI based. We're both 10G and 1G. We would sit somewhere down in your infrastructure as a backup appliance or a secondary storage appliance for colder data. That's where we would fit in an enterprise play. But for the SMB and the SME, we're your primary storage. We're going to be your primary storage that hosts your Oracle, your SAP, your SQLs, any type of, all of your databases and applications that you're running today within your mixed workloads. Or if you're running VDI, that's where we play. That's where our sweet spot's at. So let's take just a couple seconds here and talk about why are you here. These are some of the most common issues that people come to us with when they're looking for a StorTrends array. First and foremost is high latency. They've noticed their applications are starting to slow down. They're starting to see application timeouts. They're starting to see their VMs time out, where the returns from their existing storage that they're using today are not fast enough. Their users are complaining. Their applications are slow. They can't use the application. The screen becomes grainy or whatnot. It's usually a latency issue that we hear from most people. Number two on the list would be a VDI project. They're looking for a cost-effective way and an easy way, a safe way to create a VDI solution. It may be adding it into your existing infrastructure. It could be a standalone VDI project, but they're looking to add VDI users to replace desktops and become virtual. The third would be a storage upgrade. You're running on something old. You need to upgrade. You're looking at upgrading in 2016 or 2017. Maybe you've got some old compellant devices. Maybe you've got an old EMC. You need to do something, and you need to move away from it and go to a new box. The fourth would be capacity issues. Data's growing. It's growing at a crazy rate. Some of our customers we see, and we put them into boxes, and they're 100 terabytes today, and we find out in 3 years they're over 300 terabytes. So companies are growing, data's exploding, and it's growing fast, so they need to invest in more storage. It's a new build-out. That's one that we hear a lot. I've got a new IT project. It's requiring storage, switches, servers. I'm looking at all of my vendors. I'm trying to find out what I need for this new IT project. Or maybe you're just here for learning and planning. You're trying to find out 2017's coming. I need to know more about the technologies that are coming in 2016, 2017. What have you got, and how would it fit into my environment? Or maybe you're here for the last one. We put this on here. We have a lot of people that when we call them back after the demo or whatnot that they sign up for, they say, yeah, I just wanted a free pizza. I wasn't interested in your product. So if you're here today just for the free pizza, we understand. We appreciate you joining us. Hopefully we can use this time to help learn something a little more about storage, a little more about the storage industry or about our products. All right. So let's go into the all-flash, hybrid, and spinning disk overview, and we're going to start with just some very simplistic, basic information. I just want to have a level set here and just have everybody on the same page before we really dive into this any deeper. So the first box at the top, we're going to talk about a spinning disk overview or a spinning disk architecture. This is usually a mixture of HDDs. Again, it could be 15K SAS, it could be 10K SAS, it could be 7.2 SATAs or NL SASs. The 15Ks are usually used to host the hot data. The 7.2Ks are usually used to host the cold data. So on the right here, you'll see an HDD SAN architecture. You can see the HDDs in the red on the top. Those are my 15Ks. The blue 7.2Ks, SATAs or NL SASs are on the bottom. That data would tier up and down. We called that auto-tiering back in 2006, 2007. We would take the hot data, and once it became outdated, we move it down and move it into the cold tier. And then if the data becomes hot again and it gets touched, it gets accessed, those regions or those territories become accessed, we can promote it back up into the hot tier. So we would do the auto-tiering back and forth between that array. The next one's your hybrid SAN overview or your hybrid SAN architecture. This is a mixture of SSDs and HDDs. The SSDs are used either as a cache or as a tier. Some vendors have both caching and tiering in their hybrid SANs, like StorTrends. Others just have caching, others just have tiering. So there's a lot of different architectures out there from a hybrid perspective. The key point here is your SSDs would be used for your hot data, and your HDDs would be used for your cold data. That's where you would store your cold data. So on the image on the right in the middle of the screen, you'll see the hybrid SAN architecture. You'll see the cache, the SSDs, there's only 4 in this box. They're sitting in a cache. And then you see your spinning disk architectures in blue, which is where you're going to host your colder data. That's your HDDs in the box. So the next one, we're going to talk about an all-flash SAN overview. This is your all-flash SAN architecture. So these are all SSDs in the box. This is complete flash. The SSDs are used for both caching and tiering space, and they're used to host the hot data and the cold data. So if you see the image on the right bottom of the screen, you're going to see your SSDs in your hot tier, you're going to see SSDs in a cache, and you're going to see SSDs in a cold tier. So these drives are all of these drives are SSDs, they're all flash, and they're hosting your cold and your hot data at the same time. All right, so let's talk a little bit about the evolution of the StorTrends product line. StorTrends started out with a 3400. This was our dual controller. You'll see it here in the middle of the screen. This was a spinning disk architecture, 8 cores, 8 gigs of RAM. It was a 3U, and it held 16 drives. Those drives could be either 1 terabyte, 2 terabyte, 3 terabyte, 4s, or 6s from an NL SAS perspective, which were 7.2Ks. Or it could have 300s, 450s, or 600 gig SAS 15K drives in it, or a mixture of those. It scaled up to 256 terabytes, and it was a head plus 3 shelves. And we're still shipping that product today. That's still a shipping product from American Megatrends. The next is our StorTrends 3500. This was our hybrid box. So we came out with this in 2011. It was production shipping early 2012. It's got 32 cores of CPU. It's got 16 gigs of memory, so it's very light on the memory. 3U form factor, 16 drive bays. Again, it was a mixture of either your NL SAS or your SASs, and then also a mixture of your SSDs. We only used write-intensive drives in this platform. So these are 200s, 400s, 800s, or 2 terabytes write-intensive SSDs. Again, it could scale to 256 terabytes. It could expand a head plus 3 shelves, 3 expansion shelves, and we did not support deduping compression in this box, and we still ship this box today as well. And then on the far right, you have the last 2 columns is your 3610 and your 2610. So these are the all-flash brothers. So the 3610 is a 3U form factor. The 2610 is an identical software build. It's just a 2U form factor. A lot of our customers have been asking us, can we get a 2U box? Can we get a 24-bay box? They want something that's a little more dense, takes up a little less rack space. So we've listened to that, and we came out with the 2610. Both of these boxes support write-intensive drives, and they support read-intensive drives in the array. The write-intensive drives are where we're going to store the hot data, and the read-intensive drives are where we're going to store the cold data. Both units scale out to 256 terabytes. They both scale with their heads plus 3 additional expansion shelves, and they both support dedupe and compression. The 3610 is currently shipping, and the 2610 is going to ship on October 31st. So happy Halloween for the 2610. All right, so let's talk a little bit about performance. Just want to give you kind of a good peek at how these boxes stack up against one another. Now, we could have used Dell boxes, HP boxes, EMC boxes, you name it. We chose to use our own boxes just to kind of give you an understanding of how our technology spreads across each differently from the hardware build. So the red that you're going to see at the very top here, this is a spinning disk array. So this is the VMware vMark test that we run, where we run different tile numbers across it. In this test, we did an 8K workload block size with a 70% read, 30% write, and we're looking at the average latency that the box is going to put off. So you can see with the spinning disk array configured like we were talking about on the previous slide, it had SAS on the top and NL SAS on the bottom, and it's doing the data tiering back and forth. You can see that this box averages somewhere around 20 milliseconds. Throughout these tile tests. So it's kind of up and down. This is where data's coming in, it's getting flooded, it's having to influx, and it's pulling the data down, it's tiering it up, it's tiering it down, and you can kind of see it's that yo-yo pattern, and that's what you see in most arrays when you run this vMark test. You kind of see these ups and downs, you don't see a lot of flatline performance. The next one's the hybrid array, and it's in green. You can see that it starts off a little under 10 milliseconds. It kind of goes up, and then you see it start to tail off. It kind of gets better as it gets heavier loaded. So as we're adding threads and adding cues to this and we're moving up in the tile count, you can see that this box actually becomes better. It becomes a better performing box. The reason for that is that's when our cache kicks in. So the 3500 hybrid array supports both caching and tiering in the same box. So by doing that, when the tier fills up, we can switch over and use the cache until the tier can digest and move down, demote that colder data down into the spinning disk and free up more space. So instead of having a real rigid yo-yo look, kind of like what the 3400, the spinning disk array looks like at the top in the red, it's more flat. You can see that it's got more consistent performance. So after you get past, you know, the 7th or 8th tile there, you can see this thing kind of levels out at around 5 milliseconds, which is really good for a hybrid SAN. Then you'll see at the bottom is the all-flash SAN. This is the StorTrends 3610 or the 2610 platform. You can see that this thing stays in around that 1 millisecond, 2 millisecond realm. It gets under 1 millisecond throughout this test at several load levels, but it's gonna maintain somewhere around 1 millisecond. So this kind of gives you an idea of how spinning disk performs versus hybrid boxes versus all flash. So what does that mean to you? That's a great question. And it really depends on your infrastructure and your environment. So we used to talk about IOPS when we had spinning disk. Now we focus more on latency with flash and hybrid. So we want to get you the best possible latency. It means that your applications are going to be faster. It means your databases are going to be faster. It means that everything's sped up from your user's perspective as well. So now let's kind of switch gears. Excuse me. And let's talk about an all-flash hybrid SAN and a spinning disk price perspective. So on the left here, you're going to see a StorTrends 3400 in the blue box. In the center, you're going to see a StorTrends 3500 hybrid array in gray. And on the right, you're going to see a StorTrends 2610 in green. So let's just kind of compare each of these boxes and walk through this and kind of help you understand where each one comes in from a pricing perspective in 2016. So on the far left, we've got 73.6 terabytes of 3400. This is an all-spinning disk solution. Again, these are going to be 15K spinning disk on the top, in the top head, and it's going to be 7.2K spinning disk NLSAS on an expansion shelf underneath it. So we've got 73.6 terabytes raw. After we raid this out and have hot spares, we're going to have 58.57 terabytes of usable capacity. Now we call that HDD cold capacity. It's not really hot. We do perform what we call short stroking, or what we call ZBR, which is zone bit recording, where we write the most active data to the outside of the tracks of those disk tracks. That's so there's less needle movement and less platter movement when you're doing your seek on your platter checks, so that you can read that data faster, you can write that data faster because it's on the outside of the tracks. We do have those kind of technologies. We also have advanced caching built into that box, but we call this cold data, especially today compared to a flash drive. So your latency is going to be somewhere around 10 milliseconds, even up to 20 milliseconds in that box. Your ops are going to be maxed out at 4,800 ops. The rack space is 6U. It's going to use about 6,149 kilowatts per year of power, and it's going to put off about 6.1 tons of CO2 emissions. The list price of that box is $59,058. The street price is $29,782. So if you take the street price and you divide it by the 58.57 terabytes of usable capacity, you're going to come out to about 49 cents a gig. Let's transition now to the right. Let's look at the StorTrends 3500 hybrid array. The raw capacity of this box is 73.6 terabytes. The usable capacity is 49.48. The SSD hot data capacity is going to be 5.82 terabytes. So when I take just the SSDs and I do my RAID and my hot spare, I'm left with 5.82 terabytes of usable capacity from my SSD layer. And then I'm going to have 43.6 terabytes of cold data, which are my HDDs after RAID and after my hot spare. Latency is going to be somewhere around 3 to 5 milliseconds. The ops are going to be about 200,000 ops. The rack space is a 3U box. The yearly power is down. You can see it's to 5,028. The reason is that I have 6 SSDs in this box. So I've removed 6 spinning disks, so the power consumption went down. That also means your CO2 emissions go down. The list price for this box is $106,999. The street price, you can buy this from SHI, Zone, CDW, local resellers. We've got hundreds of resellers that sell this product in North America. The price per gig, if you take the $31,920 and you divide it by the 49.48 terabytes, you're going to get 63 cents a gig. So that's a really good price point for a hybrid array if you check market pricing out there today. Then on the far right, you're going to see your StorTrends 2610. This is our 2U 24-bay box. The raw capacity is 28.64 terabytes. The usable capacity is 52.28. Okay, so let's stop right here. How do we have 28 terabytes raw, but we're going to have 52 terabytes used? That's because we're doing dedupe and compression on this array. There's no dedupe and compression on the 3400 or the 3500. Those boxes do not have enough raw performance to support dedupe and compression. Dedupe and compression are performance killers in storage arrays. So an example in this 2610, if I disable deduplication and compression in this array, I can easily hit over 1 million IOPS with this box. But when I enable dedupe and compression, you can see that my IOPS drop down to 250,000 IOPS. So it does tax the CPU, it taxes the memory. There is a lot of performance overhead associated with dedupe compression. Now, what we've calculated in this demo, in this scenario here for the pricing example, the deduplication ratio we used is a 3.3 to 1. In an average IT infrastructure, if you're running VMware, if you're running Citrix, if you're running Hyper-V and you're virtualized, and you're doing a mixed workload, you're going to see around a 4 to 1 deduplication and compression ratio. That's what our customers achieve on average in a virtualized environment. Now, if you're running VDI and you have linked clones or you have pooled VDI users in Citrix, or link clones in VMware, you're going to see better than a 4 to 1. You're going to actually be up into the 5 to 1, 6 to 1. We've even got customers that are running 10 to 1s that are running heavy VDI infrastructures or installs. So it really depends on the data type as to what you're going to get from your dedupe and your compression ratios. But what we put out is that any customer that's using this in a Hyper-V, a VMware, or a Citrix environment, you're going to see around a 4 to 1 deduplication and compression ratio. So that's what we've calculated here. That allows us to throw 10.37 terabytes of hot data. So you can see our hot data is doubled in the 2610 as compared to the 3500. The cold data is 41.91 terabytes. The latency is around 1 millisecond. The IOPS are 250,000. The rack space is a 2U. We've reduced our yearly power because now we're all flash. SSDs take less power to run compared to a spinning disk, so there's less yearly power, which means there's less CO2 emissions. So you're only putting off 2.3 tons of CO2 emissions. The list price for this box is $106,999. The street price is $36,962. So if you take the $33,962 and you divide it by the 52.28 terabytes usable, you get 63 cents per gig. So a lot of customers come to us and they don't know which way to go. Do I go hybrid? Do I go all flash? I'm hearing hybrid from this vendor. I'm hearing all flash from that vendor. What we're telling the market is it's up to you, because now they're able to get into the same price realm. We're able to bring these boxes to where they're almost the same. They're identical in a lot of the configurations. In some of the configurations, if you go heavier right tier, the 2610 might be slightly higher than the 3500. But it really depends on what fits you best from a dedupe and a compression ratio perspective. How dedupable and how compressive is your data that you have today? Now, if you're out there and you're wondering, well, I only need 6 terabytes, or maybe I need 200 terabytes. Your demo was for less capacity or more capacity than I've got. What would my price point be? We have a StorTrends online price quote generator on our website. You can go to StorTrends.com. You'll receive an instant price quote on this. It'll be emailed to you from our configurator. It's just going to ask you for some input values. It's going to ask you for the capacity that you need, your max ops, your interface type, your read-to-write ratio, the application types that you have, your support level, and your support term. If you're not aware of some of those, there are I don't knows in those sections. Just drop one of those in, and then we take a worst-case scenario for you in that regard for that selection in our configurator, and then we'll email that quote out to you. So if you're interested in a price quote, feel free to go to StorTrends.com and click on the StorTrends online price quote generator. It'll be on the right-hand side of the website is a $sign that says price quote generator. You can click that, and it'll take you directly to the configurator. All right. So let's talk about StorTrends technology for just a few minutes here. So let's talk about some of the major features. If you see on the right-hand side here, in the center there, you're going to see StorTrends ITX. That's our intelligent software architecture that's on this platform, that's on the all-flash array, and it's got a lot of features that are packed into it and around it that allow us to really bring you a lot of value. First and foremost, obviously, is dedupe and compression. This is how we're able to squeeze that data. So, for example, if you have 4 terabytes today and you're using a 4-to-1 ratio, I can squeeze that down to 1 terabyte of stored space. Now, how does that help you? You don't have to buy 4 terabytes of all flash. You can only buy 1 terabyte of all flash, and we can put that entire data set on that drive. So we can use dedupe and compression as tools to help us to get the price point way low so that you can afford all flash. We also support thin provisioning. We support auto data tiering, advanced snapshots, in-lift cache, replication, and then we have our own RAID layer called RAID RT that we'll talk about in a little bit. But we do support read and write optimized flash tiers. This is another way we can reduce the price of the box and adds more value for you. The read-intensive drives obviously are less expensive from the SSD manufacturers than the write-intensive drives, so we can mix and match the read-intensive and write-intensive, and we'll talk about how we do that in a couple slides. In-lift cache, this is a highly patented algorithm that we have. This allows us to extend the SSD endurance of the drives, and it also allows us to guarantee certain performance metrics, so we can provide quality of service from a certain level from an ops perspective. So we have over 100 different configurations within this product. This allows us to mix and match different SSDs, different capacities of SSDs, different counts or numbers of SSDs, and that allows us to get to the right performance, the right capacity, and the right price point that you need. So we're not painting you into a corner. We're not trying to drive a square peg into a round hole. We're actually giving you the options that you need. We're very flexible with our product configurations so that we can meet exactly what you need. And then we're an all-inclusive feature set. There's no individual license price point. So when you buy the box, all the features come enabled in the box, ready to be used straight away. We have complete VMware integration. We support all the VAAIs. Again, this is going to be superior latency reduction. It's going to be sub 1 millisecond for almost all of the all-flash array configurations. It's going to bring a lot of value with the data compaction. We see ranges go below 50 cents per gig. So we've got a lot of configurations that are in that 50, 60 cents per gig range. And then the applications that we target are high-performance databases, mixed workloads, VDI, and then virtualized environments. So this is our StorTrends Enterprise Class feature set. This is kind of an eye chart. We're not going to go through the whole thing here. I just wanted to note that we are VMware certified. We're a TAP Technology Alliance partner with VMware. We're the elite partner, so the highest partnership you can get with VMware. We're Citrix ready, and we're Microsoft certified. We're a Microsoft Gold partner, and we're Microsoft certified. We also support KVM, so if you're using KVM and open source, we support that from a hypervisor perspective as well. Just talk a little bit about some of our other features here that kind of stand out. The Wide Area Data Services, WDS. This includes data deduplication, compression, encryption, and WAN optimization. So our replication can talk to any of our boxes at any time. So if you have if you buy an all-flash array for your primary infrastructure, you can replicate that to a spinning disk infrastructure on your DR site. So a lot of customers don't have the money for 2 all-flash arrays. What they'll do is buy 1 all-flash array, and then they'll buy a spinning disk array, or they'll buy a hybrid array, just to dock the data on cold for a cold DR strategy. Obviously, if you need something that's hot and you need an active-active scenario, we can sell you 2 all-flash arrays. They can talk to one another. We support both replication to each of those boxes. We also support bidirectional replication. So if you have 2 primary sites, 2 hot sites, you can replicate back and forth between those sites to one another. And then we support many-to-one. So if you're in an infrastructure where you have a lot of remote offices, we can put one of these units, one of the smaller units, into one of your remote offices, and then that can replicate back to one of the larger units in your centralized office or your centralized data center. So there's a multitude of features in here. If you have specific questions around any of the features or any of the functionality, feel free to put those into chat or put those into the Q&A, and we'll be glad to get those answered for you. All right, so let's talk a little bit about in-depth here about dedupe and compression. So dedupe and compression, they're not new technologies. A lot of people that we talk to, they think that these are brand new shiny technologies that have just came out. These have been around for 20 years. Most of you probably use dedupe and compression today in your back-end environment where you're doing some type of DR. where it's being archived or it's being DR'd, that data is being deduped and compressed most likely by whatever vendor you're using today. Now, these technologies couldn't be used on the primary side, again, because of the performance that they require. Deduplication and compression, when you're doing inline dedupe and compression, it's very heavy on the CPU, very heavy on the memory, and we didn't have the number of cores in the CPUs until just a couple years ago to be able to perform this inline. You'd have to have an offload engine or some type of an offload dedupe and compression CPU and memory to be able to perform this inline. But now, thanks to this number of cores that Intel packs into their CPUs, thanks to the very large footprint of memory that we can put into these chassis, there's some dual architectures out there now that can support up to 1.5 terabytes of actual RAM. We can use dedupe and compression. So the typical IT environment that we put into where our customers are running today, they're running StorTrends, they're seeing around a 4-to-1 data compaction ratio. Now, data compaction is your deduplication and your compression added together. So what does that mean? It means a customer that needs 40 terabytes, they've got 40 terabytes of data, they can purchase 10 terabytes of data and squeeze that onto it. It's still going to give great performance. You're going to see around 120,000 IOPS in an 8K, 70% read, 30% write test, and you're going to see sub 1 millisecond latency. Now, on top of this, we have what we call a mixed all-flash tier. We have what's known as a write tier and what's known as a read tier. The write tier stores your hot data. The read tier stores your cold data. So the hot tier handles all of your writes, your rewrites, and your hot reads. The cold tier handles all of your cold reads. And we do automatic data migration between those two tiers. So that data tiering is between the two tiers. It's moving the data up, moving the data down, doing the promotion and the demotion automatically in the background without any knowledge to you or your hypervisor layer or anything else. Now, we can change all of that. We have full quality of service in this box, so QoS support. We can dial that promotion up. We can make it happen faster. We can dial the demotion down. We can make it happen slower. It just really depends on where you're at and the amount of data that you have and how much hot tier space and how much cold tier space you have. And we can move that data up and down as needed, and we can touch those policies and make them act as we need them to act for your specific environment. So we can tune it to fit your exact needs. The deduplication and compression algorithm is highly patented. There's 6 U.S. granted patents on this already. A lot of our competitors that are in this space, they don't even have 6 granted patents on their technology as a whole. So we're really proud of the fact that we've created this a while back. It's something that we architected, it's something that we proofed, and it's something that we're able to bring to the market with a lot of confidence, knowing that it is a superior technology in the industry. The next thing I want to touch on here is StorTrends Inlift Cache. This resides on the eMLC SSDs. So in all of these boxes, all of our all-flash boxes, and even our hybrid box, we have a small set of eMLCs. These are enterprise-class MLC SSDs, and we have what's known as Inlift Cache on this. So what is Inlift Cache? Inlift Cache does 2 things. It provides extreme performance to the box, and it also protects all of the SSDs in the box from running out of any type of endurance. So these enterprise eMLC drives, they're going to give 10 drive writes per day. So we're able to guarantee 5 years of endurance from all of the SSDs in the box because of this protection layer that sits in the front. So this is where we collect all of the net new writes and we collect the rewrites and we store them and then we consolidate them and send them downstream at one time. So the diagram on the right over here kind of explains that process. So the first image on the left side here, it shows how read data is coming from block Z in the read tier and write data is going in where block Y is residing on the write tier. That's how your typical reads and writes occur from an SSD tier architecture. But the next image on the right over here shows what happens when a rewrite comes to block Z. So block Z is already residing in the read tier. Instead of sending a rewrite downstream to the read tier, we send it into the Inlift Cache zone. And that's where it will sit until it's a consolidated write, and it'll make one consolidated write downstream into the read tier. This is how we don't blow the read tier drives out. So SSDs are what's known as program and erase cycles for their cells. You can only program the cell and erase the cell so many times before you wear that cell out. So an analogy I like to give here is if I gave everyone on this webinar today a piece of paper and a pencil, and I had you write down a 1 and erase it, write down a 2 and erase it, write down a 3 and erase it, by the time you get to 10 or 12, there's going to be a hole rubbed in that piece of paper because we've erased it so many times. The same thing happens with the cells within the SSDs. They wear out. Now, they don't jump out of the drive and run down the street with their hair on fire because they're out of PE cycles. What happens is that cell will actually convert into a read-only cell. So it no longer can be programmed, it no longer can be erased, it's just used as a read-only cell. That's exactly why we created nLift Cache. It protects those cells from being worn out before it's time. So it prevents any kind of premature wear to the cell. The other reason is for performance. So nLift Cache is used as a performance buffer. So when you're doing data migration and you're starting to migrate data, if you migrate data down into the read tier and it's being deduped and it's being compressed as it's going into the box, it's going to bog. If you're trying to do live migration through VMware and you're doing your vStorage, you're going to see latency spikes. You're going to see your VMs disconnect. Now you've got performance issues. So you're trying to do a migration, you ran into performance bottlenecks, VMs dropped off, you're in trouble. Well, with nLift Cache, what we do is if the migration hits a point like that and it becomes saturated because it's overloaded, we will use nLift Cache as the buffer to handle all of those incoming data writes and reads going in and out until we can actually move that data downstream and migrate it. So for migration, for snapshots, for any writes, reads, rewrites that come into the box, the nLift Cache is the performance buffer, and that's how we guarantee those 231,000 IOPS that you're going to see in that box from an 8K layer. All right. So this is a very common question that we're asking. I noticed that it was asked several times by people that registered. It was very redundant throughout the registration questioning process. Do I need an all-flash array, a hybrid array, or do I go with another HDD array? What do I do? Here's what I've got. I'm using this, and where do I need to go? The way I start with this question is I tell people it depends on your data compaction ratio. What is your data? Is it dedupable, and is it compressible? If it is, and you have a 3-to-1 or higher, you are a really good candidate for data compaction, which means that you need to go to an all-flash SAN architecture. But if you're less than 3-to-1, let's say you're a 1.5-to-1 or a 1.7-to-1, you need to look at a hybrid SAN architecture. We actually have a tool that is a deduplication analyzer. It'll actually walk through your database and look at the number of blocks, and it'll come up with the number of matches. So we can take a small piece of your database and we can tell you what your deduplication and your compression ratio is going to look like. That way you know with confidence, is it a 2-to-1, a 3-to-1, a 4-to-1, or a 5-to-1? Where do you fit, and what's the best way for you and your data set to move forward? Is it hybrid or is it all flash? An example, I did an installation not too long ago, a few months back here in Atlanta for an architectural firm. The gentleman wanted all flash. He wanted all flash. There was no questions about it. We had him run this tool first before we sold him an all-flash array. He was running a lot of CAD. He was running a lot of Revit. He's an architectural firm. So his data was not very dedupable. His data was not very compressible. So what ended up happening, he ran the tool. He came back. He had a 1.3-to-1 deduplication and compression ratio. He could have gone all flash, but it would have cost him a lot more money. So he found that there was a lot more value in the hybrid in just buying the SSD sizes and capacities that he needed and the count that he needed to keep his hot data. And we've got another tool that we call StorTrends iData that can run in your existing infrastructure. It runs on your existing servers, your storage, or at the hypervisor layer, whether you're using Microsoft Citrix or VMware. And it's going to watch your data for a week, and then it's going to come back and it's going to tell you, and it's going to give you a full breakdown of a report that's going to give you an analysis of how much hot data you have versus how much cold data. So that way he knew exactly how much SSD space he needed for his hybrid SAN architecture for it to work proficiently in his infrastructure. So again, he was a poor data compaction candidate, so he ended up choosing the hybrid SAN route. All right, so we were just talking about the StorTrends iData tool. This is a tool that can be downloaded from StorTrends.com. It's a free tool that you can use. It sets up in just a few minutes. It's very non-intrusive. It doesn't generate any I/O. It runs for 7 days on your existing equipment. So what it's going to do is it's using the existing performance tools that are there. So for like Windows, it's using the WMI. It's tying into those layers, and it's watching all of the data blocks. At the end, you're going to get a very good report that looks like this on the right. It's going to be a summarization. It's going to tell you your capacity usage, your IOPS, your reads versus your write ratio. It's going to tell you your network utilization versus your bandwidth. It's going to identify all of your peaks and your percentiles there. The key thing here is it's going to tell you what your hot or active data is versus your cold data in your environment. A lot of IT managers, IT directors, they don't know hot versus cold. When you ask them this question, they go, I don't know, I got 30 terabytes, I can't tell you how much hot's or cold. This is a tool that will be able to determine how much is hot and how much is cold by watching all the changes that come in during that 1 week period. That way we can make sure we spec you for the right product so you know exactly where to invest money into your next infrastructure. Whether you buy our product or a competitor's product, at least you go in with the needed information knowing how much hot data you have versus the cold data. All right, last slide and then we'll jump into the demo. StorTrends support the StorAid experience. If you ask 10 of our customers, if you called 10 reference customers today that are StorTrends customers, and you said, tell me the number one thing you like most about StorTrends, they're going to tell you it's the StorAid support. It's based out of Atlanta, Georgia. It's 24/7 for support. One of the things we do differently is we use storage engineers. These are guys and gals with computer science degrees. They have either electrical engineering, computer science, or some type of an engineering degree. They're not help desk technicians. They're not going to just take your information, pass you around 3 or 4 times, try to get you to a level 1, level 2, level 9, whatever kind of a support. These are going to be storage engineers that eat, breathe, and sleep storage that can fix your issue when you call in. These are guys and gals that know their stuff and they take care of the problem immediately. And that's the number one thing that most people like about us. If you're trying to do something at 2 o'clock in the morning and you've got a question, the last thing you want to do is it to take 2 or 3 hours to get back to you with what action you should have taken in the array when you're trying to make whatever change. You want to need to know an answer immediately, and that's what we provide. We offer 4-hour on-site and next business day on-site support. No downtime maintenance because there's a dual controller architecture. We can upgrade one controller at a time, so you no longer have to do this at 3 o'clock in the morning. You can do this on your time. We offer schedule upgrade assistance where we have one of our StorTrends engineers available to assist you at any time you're doing an upgrade. We do proactive health monitoring. These are our email alerts. This is called Store Vitals. It's a cloud that we use where you push the emails from the box to our cloud, and then we monitor that cloud 24/7. So a lot of times we'll actually tell customers things fail before they find out that they failed. We'll call them and say, hey, you had an alert, you had a power supply fail in your array, we've got you a power supply that's going out. It'll ship in the morning and it'll be there tomorrow afternoon at 2. SSD guarantee endurance. We guarantee that the endurance will not run out of these drives for 5 years, and the support terms are 1 to 5 years. So again, StorAid experience, it's really remarkable. It's something that we really stand on from a company perspective and we stress a lot. All right, so let's go into the demo really quick. I know we're running kind of short on time. We've only got about 7 minutes. Just kind of want to show you what it looks like. Let me jump through a couple slides here. So this is our all-flash array. When you first log into the box, you're going to come into the base server. There's obviously credentials that you would log into, username, password. You can get to this through Chrome, Firefox. We also have a plug-in so that you can manage this. This is HTML5, so you can manage this from your iPhone, your iPad, your Android, or whatnot. If you have multiple units from StorTrends, you're going to see these units display in the top as long as they're in the same subnet. So you're going to see those pop up here. You can instantly click on that, and it'll take you to that box so you can manage it. So you can jump from box to box. You don't have to worry about logging into all the different types of arrays or going into different IPs. They're all in one location. When you first come in, the first thing you're going to notice is a storage statistics page. You're going to see this is at the storage pool level. And I've got a tab here that's the volume statistics, and I'm going to show you those in just a few minutes. But the first thing I want you to see here, the physical capacity of this box is a 4.55 terabyte. Now that's after my RAID, after my hot spares, I have 4.55 terabytes of physical use. But my predicted capacity is a 38.44 terabytes. So I've taken 427.46 gigs of actual data space is what's stored on this box. But there's really 3.53 terabytes of used space on the box. So you as the customer have 3.53 terabytes. Me as the vendor, I've squeezed this down to 427 gig. That's a data reduction of an 8.5 to 1. So this is high. This is very high. And the reason why I'll show you in a minute, I'm running Citrix VDI users on this. I'm also running some VMware Horizon View users on this. I have the link clones enabled, so I've got a lot of duplicate data that's sitting in here in the array, and that's one of the reasons that the DD ratio is above a 4 to 1. Again, if you're running a virtualized environment today, you're probably going to see a 4.0x ratio top number, and it's going to be reflected in your predicted capacity to your physical capacity. We also show you the predicted free space. You can see there's 34.91 terabytes of predicted free space, and then we really give you a good glimpse because we show you the physical free space. So you get the physical capacity and the physical free capacity of the box. When you log in, you're going to notice new events. If anything critical or warning happens, like if you drop a NIC, if you have a NIC flapping, if you lose a drive, a power supply, a fan fails, anything like that, you're going to see those events happen here. Those are going to pop up as warnings or as criticals. We also track all of the drive status, so we keep a check on the health status of the drives, and we keep a check on the temperature status of the drives. And I'll show you the GUI management screen in just a minute for managing that. We get into the performance aspect of the box, and we show the latency, we show the ops, and we show the throughput. So you're going to see here my read latency is around 0.4 milliseconds. My write latency is a 9.28 milliseconds. So this is very high. The reason why, I had a switch die this morning. You got to love live demos. I had a switch fail this morning. I had to change the switch out. I forgot to set the MTU settings to jumbo frames on my switch. So right now my switch is set at 1500 MTU, and my storage box is expecting this to be jumbo frames enabled, so it's showing an insanely crazy number here because I've got mismatch on my packets here. You're going to see the op perspective. I'm running about 26,000 ops and reads, and I'm running about 10,000 ops and writes. So instantaneously, I've got 37,000 ops. Hourly, I'm averaging about 36,000 ops. So this box is cooking pretty good right now with the data that I've got on it. You're going to see this is 416 megabytes per second read throughput, and it's 44 megabytes per second write throughput. It's going to break down my read and write ratio, my little donut here. It shows me that I'm about 71% read, 29% write, and then it gives you an understanding of what your block sizes look like. So my reads are coming in 16Ks right now, and my writes are going out. Our writes are coming in at about 256K size here. Sorry, 4K size here. Then you can jump into your volume statistics. So this is going to break it down at the volume layer. So we can see here the first volume that I'm clicked on, this is run 3600. You can kind of get an idea of what the ops look like. You can kind of get an idea of the latency and the throughput, and again, the same breakdown, so the same charts. If I click on a different volume, you can see that the statistics will change. So we'll go to ATL setup here. I know I've got some data running on it. You can see that the data updated itself here in the chart. You can actually dive into these charts and get granular with it and really find out what's going on. You can take a historic graph view, so you can pull this from previous hours so that you can kind of track this of what's going on in your array. This just helps you get an overall performance aspect of which of my volumes are doing well, what's kind of dragging, what's going on in the overall array. So really quickly, I want to jump into the event log here. I think I clicked on hardware health by accident. I fat-fingered this. So hardware health, this is going to show the health of the box. It's a 3D representation of the array. So you can see here, this is 3600 that I'm showing you right here of our all-flash array. It's got 16 drives in this box. You can see that it breaks the drives up. These are my write-intensive drives on the outside with the gold stars. These are the read-intensives with the green stars. So it tells you it's a read-intensive SSD. It tells you the serial number. It tells you the capacity, and if it's online, it also tells you the slot number. You can see the I/O by the metrics moving up and down. You can see the little blue bars, the yellow bars, and the red. That's showing you the I/O load that's on each of those drives. If I want to flip this thing around, I can actually take a view of the rear view of this box. So this is something that's kind of neat. I pulled a power supply 2 days ago just so that I could show a customer what would happen in the event that the power supply failed, just simulating a failure. So you see you get a red bang and it's bad. The same for this NIC output. I've got a NIC that I pulled out, this red NIC here that's telling you it's down, so it's NIC 5. So you can kind of get a good understanding of what's going on from the box. If there's additional enclosures in the box, when you click on enclosure, you'll actually see the additional shelves that are stacked below it. You can see here my right controller, it's running at 1%, 2% CPU, 9% memory, but on the left controller, I'm 73% CPU and 59% memory. This is because the left side is my active controller, the right side is my passive controller. So that any time the left side fails or has any type of a failure, a network failure, NIC failure, any type of a power failure, anything that goes on the left side, it'll automatically fail over to the right side. It's seamless to VMware or anything else that's sitting there. So that's kind of we're going to have to do just a very abbreviated demo today. I could kind of go through these volumes and show you some of this stuff and get more in tune with some of our features, but unfortunately we're out of time. If you'd like to schedule a one-on-one demo, please contact Tyler Newberry at tylern@ami.com, and he will set you up with a solutions engineer to go through a very detailed demo with you, answer any questions that you've got about the specific product, the functions, or the features. So we're going to jump into just a couple really quick questions. We had a lot of questions come in that were, there were a lot of duplicates sitting here, so we're going to jump into this. One of the questions was, what SSD drive manufacturer are you using in your all-flash SAN? That's a great question. We use Samsung, we use SanDisk, and we use Micron SSDs in different form factors in these boxes. So next question from Dante in Virginia was, do you sell through SHI or zones for government? Yes, we sell through both of those. We also sell through CDWG. So Dante, if you'll contact Tyler at tylern@ami.com, he'll route you to the proper sales rep that can get you in touch with whomever you need there from a government aspect to buy. The next question was from Becky from Colorado. We want to run VMware Horizon View for VDI, and we'll have around 1,500 VDI users. Can the StorTrends 2610 support this configuration? Yes, it absolutely can, Becky. We've actually tested the 2610 through our performance lab with up to 3,000 VDI users on the box, with a single configuration. So, yeah, you're about half of the load that we've qualified on this box. We can absolutely support those 1,500 VDI users. Todd from Georgia, can I replicate my existing StorTrends 3500 hybrid to the StorTrends 2610 all-flash SAN? Yes, Todd, you absolutely can. You can do bidirectional replication between those two boxes as well if you need to, if you want both of those to have primary or active data on them. The next question was from Jack from Minnesota. Our environment runs heavy SQL loads that generate over 20,000 ops. Can your all-flash array support this workload? Yes, it can, Jack. Through our testing with SQL, we can actually support up to about 65,000 ops. They're heavy SQL loads. If you want to get into some details of that, we can share some performance lab results with you, talk about the block sizes and how we handle those in our deduplication and compression engine, and give you some more background on how we handle those SQL loads. Next question, and then we're going to end here shortly. Fred from Ohio. We are looking to replace our Dell EqualLogix PS arrays that are old and slow. We need to consider either hybrid or all-flash. What is the best? Okay, Fred, that depends solely on your data. Do you need, what does your data set look like? Are you going to have a good deduplication and a good compression ratio? So is your data compaction above a 3-to-1? What we see is if it's below a 3-to-1, usually price-wise, the all-flash is more expensive than the hybrid. But you have to consider how much hot data you need as well. If you need just a couple terabytes of hot data for those arrays, then you can probably go with the hybrid and save some money. But if you have a really good deduplication and compression ratio, all-flash is going to be cheaper than hybrid. All right, just a couple more here. Pete from North Carolina. How do you grow the SAN after the initial install? Meaning, what do we buy if we fill it up? Okay, good question, Pete. You're going to buy an additional expansion shelf. Those expansion shelves fit underneath the head. It goes directly into the storage pool. It's instantaneous, additional add. You don't have to repower, shut down, bring anything else up. You simply plug the enclosure in. It automatically detects and sees the data. It's going to have a configuration on it before you get it, a certain RAID set with hot spares already set up per your requirements. And then it's just added to the storage pool and it's ready to use. And again, we can mix and match the write tier and the read tier based off your requirements at that time, Pete. So if today you have just a little bit of hot data, but maybe that hot data grows in the next 2 or 3 years, we can put more hot space, more write-intensive SSDs in the next array, the next expansion shelf, and help you balance that load out. All right, and then we'll do this last one, and then we'll leave here. Jeff from Connecticut, how much hot tier should we need if we have 20 terabytes of data today? Okay, Jeff, there's really not a good rule of thumb. I have done installs with customers where they have less than 10% hot data. I've performed installs where they have more than 30% hot data. It really depends on the applications you're running and your business type. This is one of the reasons we created that StorTrends iData tool. It's something that plugs into your environment. It takes about 10 minutes to install it and configure it in your infrastructure. It's really easy to run. It runs for 7 days silent in the background, and then it's going to give you a detailed report that's going to tell you exactly how much hot data you have. So let's say, Jeff, you come back and you're 3 terabytes hot data. We would want to spec out 4 or 5 terabytes for you based on your growth, and then that's the configuration that we would provide you for the 20 terabytes that you need. So I would highly recommend downloading the StorTrends iData from our website, from StorTrends.com, and running that tool. All right, well, Tyler's telling me we're out of time. We greatly appreciate you guys and gals sticking with us today. Sorry that I was a little long-winded in the presentation. Again, if you have detailed questions or if you need anything from a pricing perspective or anything like that, feel free to reach out to Tyler. You can contact him at tylerin@ami.com, and he'll be glad to route you to the right representative or the right contact within the StorTrends division to get your answers to your questions. All right, thank you very much for your time, and y'all have a great day.